Okay, so I'm going to give a quick demonstration of the ion wind propulsion demonstrator. The demonstrator is the 3D printed white PLA plastic structure and electrodes that you see here. The rest of the system behind it is basically just there for the generating of the high voltage DC current as well as measurement. So let me do a quick overview of how the system works. Forgive the wiring, which is currently duct taped to the table, but all of the dangerous components are safely locked into that PVC box. And the wiring has been carefully arranged such that no two wires of high voltage that are of opposite polarity come near each other. Now, starting over here, we have the 0 to 24 volt, 20 amp capable switch mode power supply, the activation switch, going over to the high voltage generator, which uses a ZVS driver, a zero voltage switching driver, which is basically a MOSFET circuit that is used to drive a flyback transformer inside, which is what inevitably generates the high voltage DC signal. Although it is DC in that the polarity does not flip between that red output wire and the black output wire there, the one that goes into the green line, it isn't a smooth signal. But that doesn't matter. As long as the polarity doesn't change, the system, the effect should still work. So then that is connected to the demonstrator. As you can see here, the needle is connected to one side, and the duct, which has lined with aluminum tape on the inside, is connected to the other electrode. So, and then in parallel to that, we have a voltage splitter here, which is basically reduces the output voltage by a factor of 1,000. So that the multimeter over here can read the output voltage of the high voltage generator without frying itself. So whatever this voltage reads, multiply that by 1,000, and that is what the actual voltage that we're seeing is, or roughly. This isn't exactly the most expensive measurement equipment, nor is it the most expensive generating equipment. So this is all kind of ballpark, but as I said, this is just for demonstration, not for actual prototyping of an actual propulsion system, because trying to scale this down, well, there's a reason that the team at MIT won awards for what they did. Anyway, let's begin. I'm going to put a background here to make the smoke more easy to see, because I'm going to use a burning splint to demonstrate airflow between them. Just as a note, for anyone not very experienced with high voltage equipment, do not try this at home. I have been working with high voltage equipment for quite a while. I'm quite experienced with it at this point. And I know my equipment quite well. This is not something that you can just mess around with. This is something that could be potentially lethal if you touch the wrong part of the system at the wrong time. With that said, let's begin. Background for contrast so we can see the smoke. I'm going to make sure it's actually focused this time, because this isn't the first time I've tried filming this. And hopefully this time I remember to pan the camera over to actually see what the voltage reads. So first off, I'm going to demonstrate without it on. The smoke rises straight up. Now I'm going to turn the system on. And then off. And then on. And off. And on. Okay, now with it on, let me pan over so we can see what the voltage is reading. Okay, looks like we're getting about 12,700 volts, roundabout. Well, there you have it. I'm going to turn it off, and I'm going to remove and extinguish the splint. Thanks for watching.